Hello everyone. Today we are going to discuss about the projectile motion from mechanics. It is one of the most important topics for the HS second year students. Okay. So let us see what is a projectile. A projectile is an object that is thrown into the air and then it moves under the influence of gravity alone. So what is a projectile? Means a projectile is any object when it is thrown into the air. If it moves only due to gravity, no other external forces acts on it, it is known as the projectile. Particles are known as projectile. Okay, so the examples of projectiles are a bullet fired from a gun, okay, a cricket ball thrown in any direction. If you have played cricket, you can easily visualize it that when a cricket ball is thrown, it solely moves under the influence of gravity. An athlete doing the high jump, okay, these all are examples of projectile motions. Okay, so these are the examples of projectile motion. Now let us discuss how the projectile motions works. Okay, so for understanding this, we have to consider a graph basically. Okay, so you can see the graph I have drawn in the paper beside. This is the y-axis, this is the x-axis, and this is the projectile motion. If an object is thrown from O, it will traverse a parabolic path, okay, where this is the parabolic path. Okay, so when the object is thrown, say initial velocity from this point O, the object is projected or thrown with an initial velocity v0 at an angle theta. This is the angle theta with the horizontal axis. Okay, so it first reaches up to a maximum height p. Okay, this is the maximum height p. From it is the maximum height, then from p it starts descending. Okay, and the distance from which it falls from the origin is r, that is OD is equal to r. So at any instant it will have two components, one is parallel component, one is vertical component. They are also vertical component. This is the vertical component, this is the parallel component. So the fact is that the parallel component is not responsible for the motion of the projectile. Okay, only the vertical component is responsible for the motion of projectile. So if this is v0, then this is the horizontal component v0 cos theta, okay, and this is the vertical component v0 sin theta. So v0 cos theta is not responsible, so ax equal to 0, because v0 cos theta is constant, so acceleration will be 0 in the direction, and v0 sin theta is only responsible for the motion of the projectile. Okay, so this is the basic thing which you must keep in mind, that v0 sin theta is the agent that is causing the motion of the projectile. So let's see how there are many parameters in this motion. So let us see what are the parameters. Okay, let us see which parameters are there. So one more thing, this is the origin, so time, so this is the instantaneous time, okay, and this is the time of flight t, which will be coming later, that when the journey is complete. So let a projectile or object is thrown or projected from O, means it is thrown from O with an initial velocity v0, this is the initial velocity v0, at an angle theta with the horizontal, this is the theta angle with the horizontal, that is the x-axis. Okay, the projectile rises to a highest point p. Okay, it rises up to highest point p, this is the maximum height or unstable position, then it starts descending from that point. Okay, so this is the basic motion of a projectile. Okay, you must keep in mind, this is the motion of this projectile. It reaches a maximum height p and then it starts descending. It finally strikes the ground at a point D at some horizon from the point of its projection, means from the point of its projection it moves a parabolic path, reaches the height p, then it starts descending and reaches the point D in the ground at a distance of r from the point of projection, that is O. Okay, so this is the distance or the horizontal distance from the point of projection, that is r. So here theta is the angle of projection, means the angle from the horizontal at which it is projected, okay, and r is the horizontal distance. Now as I have told you, the acceleration along the x direction is 0, since v0 cos theta is constant. Okay, since v0 cos theta is constant, acceleration is 0. However, the vertical velocity v0 sin theta is under the action of gravity, and its value goes on changing during the projectile motion. Since v naught sin theta is causing the motion, it is only responsible for the projectile motion, okay, as I've told you. And if v naught cos theta is constant, that means if v is equal to constant or v naught cos theta is equal to constant, then acceleration is dv by dt, we know that is the rate of change of velocity. If velocity is constant, then the rate of change would be zero. Differentiation, you can say, of any constant thing is zero. So the acceleration along the x direction is zero. This is the basic thing. That is the reason I'm telling it again and again. Okay. So let us see. Let us see what happens now. Now, if we talk about the trajectory, okay, the trajectory means the path that is followed by the projectile. Means if a particle traverses something, it is a trajectory. That is the path. If this is the particle, if a particle moves like this, then this path which is it has followed, it is the trajectory of the particle. Okay, and for this trajectory, because it follows as a parabolic path, the trajectory is parabolic. And there are certain parameters which are need to be find out, or in the exam you are told to find out. Okay, that is the time of flight t. Okay, the time of flight is the time when the projectile hits the ground from the point of projection. It is the time of flight. Okay, it is the time of flight. So the next one is the maximum height attained, that is h max. This is h max. Okay, and next one is the horizontal range, that is the distance from the point of projection to the distance r, that is r. So these are the three parameters which are need to be find out, or you are told to find out in the examination. So let us find out them. Now let us see the time of the flight. So I have drawn the same diagram again. This is the parabolic path, this is the initial velocity, this is theta. Okay, so at t, this is t equal to 0, and at this point x equal to 0, y equal to 0, because it's origin. So at any particular instant, this is the y component, this is the x component of distance. Okay, right, and suppose this is the point, this is the y component, and this is the x component of the distance. So at this point where the particle hits the ground, it has no y component, that is y equal to 0. Okay, y equal to 0 and x equal to r, right? So it is the time taken to reach the ground again from the point of projection, right? From the point of projection, the time taken to reach the ground is time of flight t. T is the instantaneous time, so at time of flight t will be capital T. Okay, so we know the famous equation s equal to ut plus half at square, where u is the initial velocity here. Okay, so it is v naught sin theta, and distance is the y component distance, because the velocity is in the y direction. The horizontal distance is not necessary, because horizontal velocity is not changing. So it is y equal to v naught sin theta into t minus half gt square. It was plus half at square, but gravity is always acting downwards, that is why it is a equal to minus g, a equal to minus g. So it is causing the acceleration, so it is minus half gt square. Now for the time of flight, t is equal to capital T. Okay, small t is equal to capital T. Okay, is it right? And the y is equal to 0 at the time of flight, because at that point the particle reaches the ground, so y is equal to 0, y equal to 0. Then putting these things back in the equation A, if we put, then y equal to 0, it is v naught sin theta into capital T minus half g small t is capital T whole square. Okay, now if we take t as common, it is v naught sin theta minus half gt is equal to 0. Now there will be two solutions. For t equal to 0 means at the launching time, at the point of projection, the t is 0, right? And next one will be v naught sin theta minus half gt is equal to 0. One is this time. Okay, this is the point where t is equal to 0 on the origin, and this, if to solve it, half gt is equal to v naught sin theta, then t is 2 v naught sin theta by g. This is the time of flight. T is equal to 0 is not taken, only t equal to 2 v naught sin theta by g is taken. Now time of ascent equal to time of descent. What is this? If the projectile moves up to the maximum height, So up to that point, the time which is taken is known as the time of ascent. Ascent means increase in the time. Okay, this is the time of ascent. And from that particular height, when it starts to fall down, it is the time of descent. Descent means coming downward. It is the time of ascent and time of descent. Okay, now we can say that if time of ascent plus time of descent, say I am writing time of ascent as TA and time of descent is TD, then if time of ascent plus time of descent equal to T, and they both are equal, so we can write twice TA equal to T or TA equal to T by 2. Time of descent is also equal, it will be T by 2. So if we add them, T by 2 plus T by 2, it will give us T. So time of ascent equal to time of descent. Okay, so time of ascent equal to time of descent equal to T by 2, and T we know twice V naught sin theta by G. If we divide by 2, it will be V naught sin theta by. So this is the equation for time of ascent. Now let us talk about the maximum height attained. So it is the maximum height the projectile rises before it starts to descend. Okay, so when it starts from here, this is the maximum height h max. This is the point from which it starts to descend. Corresponding to this point perpendicular to x-axis, the height is h max. So this is the maximum height of the projectile. Okay, it is the maximum height the projectile reaches before it starts descending. Okay, now writing the same equation, y is equal to v naught sin theta into t minus half gt square, as we wrote it previously, the previous page. Okay, so we know that at maximum height t is equal to t by 2, it will be half the time. Okay, it will be the half the time. Okay, it will be half the time, total time of flight. So it is t by 2, and t by 2 is v naught sin theta by g. Right, t is twice v naught sin theta by g, so t by 2 is v naught sin theta by g, and the height, that will h max, that is why you can write at h max, because it is the maximum height attained by the projectile, and it is a vertical height. As I've told you, we need to take the vertical height, that is y is equal to h max for time of flight. So h max equal to v naught sin theta by 2 into t by 2 minus half g t square by 4, or you can write t by 2 whole square. Okay, so after solving it, it is v naught sin theta by g, half g t by 2 is v naught sin theta by g whole square. So it will be v naught square sin square theta by g minus half v naught square sin square theta by g. So after solving it, it is v naught sin square theta by 2g. So it is the maximum height attained by the projectile during its motion. So let us talk about the horizontal range, that is the distance at which it strikes the ground from the point of projection. That is the horizontal range of the particle. Okay, so it is the distance traveled by the particle before returning to the ground. Okay, so it is r, that is the horizontal range, distance attained by the particle before returning to the ground. Is it clear? I hope it's clear. It is the distance that is from the point of projection to the point where it hits the ground. Now we know s is equal to vt. Okay, now as I am talking about horizontal range, from horizontal it will be horizontal distance x, and the velocity will be obvious, horizontal velocity, because we are talking about horizontal range. So it is v naught cos theta. If the v naught, this is the horizontal velocity, v naught cos theta, right, into t. So x is any distance in the horizontal at time t, means time t is the instantaneous time. Okay, this is the general equation, x equal to v naught cos theta into t. Now at the time of flight, small t is equal to capital T. Okay, small t is equal to capital T, and x is equal to r. Okay, so we can replace it, t is equal to capital T, so x is r, v naught cos theta remains as it is. I have skipped a step, let me write it. So it is v naught cos theta into, it is twice v naught sin theta by g, which is the value of capital T. Now if we solve it, it is 2 v naught square sin theta cos theta by g, and these 2 sin theta cos theta will give us sin 2 theta, that is v naught square, and by g remains as it is, and 2 sin theta cos theta is sin 2 theta, and it is the value of the horizontal range of the projectile. Okay, so everything is fine. Now let us talk about the special conditions, that is the condition for maximum height. Now h max is v naught square sin square theta by 2g. So this is h is maximum when sin square theta is maximum, that is 1. So at theta is equal to 90 degree, that is at theta is equal to 90 degree, sin square theta is maximum because sin theta is maximum. Okay, so it is v naught square by 2g. So maximum height attained by the projectile is v naught square by 2g if it is thrown at an angle 90 degree. So let us see what will be the maximum range. So maximum range for this is v naught square sin 2 theta by g, and it is v naught square sin 2 into 90 degree divided by g. So v naught square by g sin 180, and sin 180 is 0, so the range is 0. Okay, so h max is v naught square by 2g and range is 0, means a particle, if it is thrown at an angle 90 degree, okay, it will reach a maximum height, that is v naught square by 2g, and again it will return to the ground. Let me draw it nicely. Okay, so it is drawn here. So a particle when thrown at an angle 90 degree, it reaches a maximum height v naught square by 2g and returns to the ground because the range is 0. So the range is 0, so it is not a projectile motion, because projectile motion focuses on the range. It must follow a parabolic path to have some range. So it is going vertically upward and coming down, so it is not a projectile motion. We have to focus on range, that is range must be maximum. So let us see what is the next case, the case where the range is maximum. Okay, so the condition for horizontal maximum range. Okay, so we know that the projectile focuses on range, that is if range is maximum, the projectile motion is a well projectile motion, means a well defined projectile path will be available. Okay, so we know v naught sin 2 theta by g. So r is v naught square sin 2 theta by g, and r is maximum when sin 2 theta gives us 1. So sin 2 theta gives us 1, and when it will be 1, when theta is 45 degree, then only 2 into theta will be 90 degree, so that sin 90 is 1. Okay, so if you put sin 90 as 1, r will be v naught square by g. That is if the projectile is projected with a velocity v naught at an angle theta, that is 45 degree, it will get the maximum range of v naught square by g. Okay, so r max is v naught square by g. And let us see what is the height attained. So h max for this case will be v naught square sin square theta by 2g, v naught square sin square 45 by 2g, as theta is 45 degree. So sin square 45 is 1 by 2, because sin 45 is 1 by root 2. So it is equal to v naught square by 4g. So h max will be, for this case, is v naught square by 4g. Okay, h max is v naught square by 4g. So as we are seeing that the projectile motion is with maximum range, so this is a projectile motion. The previous motion was not a projectile motion. I hope the video is clear to you, so you can share it if you like it, and if you have any doubt in this video, you can comment in the comment section below. Thank you.